Hello everyone, my name is Eddie Hudson. Today I'm going to be talking about our ICRA 2022 paper. Our paper is about an algorithm called Xylem, or Skeletal Feature Compensation for Imitation Learning with Embodiment Mismatch. As suggested by the name, we developed Xylem to address the problem of imitation learning with embodiment mismatch. Embodiment mismatch in imitation learning happens when the expert that is used to generate the demonstration data has a body that is different from that of the learner that is using that data to acquire the desired skill. As an example, in one of our experiments, the expert is the classic half cheetah, while the learners are a series of half cheetahs with a progressively longer torso, as in this example. We derived Xylem by modifying GIFO, an adversarial imitation learning algorithm. In the discriminator training phase of GIFO, we first obtained some trajectory rollouts from the learner's policy pi. Then, we obtained state-next-state pairs from those rollouts. We also obtained state-next-state pairs from the expert demonstrations, and then we trained a discriminator to distinguish between data from the expert and data from the learner. The first modification we make is to wrap each state with an abstract function g before passing it to the discriminator. We refer to G, or rather the outputs of G, as skeletal features. We designed skeletal features to make the embodiment mismatch problem more tractable. So for toy domains like the half-cheetah domain I briefly talked about, G is simply the identity function. But for more involved domains like in our experiments involving human demonstrations, we have a slightly asymmetric definition of the skeletal features. As an example, when we were dealing with human demonstrations, we defined one G function for the human demonstrator and a separate G function for the humanoid learning agent. Even though we used two different G functions, both the G functions computed the same list of quantities. Note that the G function only takes the difficulty level of the embodiment mismatch problem down a notch to a point where we can use gradient descent to address the problem. The G function does not solve the embodiment mismatch problem entirely. After defining the skeletal features for both the expert and learner, we pass the skeletal features from the learner through an affine transform F before it reaches the discriminator. We then train F like it was a conditional GAN. More specifically, we apply these training steps in Xylem. We first update the discriminator D using supervised learning, then we update the policy using PPO where the reward comes from the discriminator D. Finally, we update the affine transform F by optimizing this loss function. Using Xylem, we were able to train simulated humanoid agents to walk by observing human demonstrations. In our paper, we also show results on toy domains involving half-cheetah and ant. We also produce quantitative comparisons against competing approaches. Punct20 and TPIL are the competing approaches we compare against, while Xylem minus is an ablation of Xylem that does not have the affine transform in its training structure. We show that Xylem is able to outperform all of these approaches. With that, I've come to the end of this talk. I'd like to thank you all for your attention, and I'm ready for any questions now. Thank you.